Okay, so I am going to do a walkthrough of serverless Go. There's a lot of questions that are asked of this code lab, and I think it just helps to go through and give you an idea of what we're looking for here. So the first thing, the site itself is located at sg.org and ctf.org, and this will redirect you to where the vulnerable application actually resides. And then you'll see, just like the code lab, you'll see that you're given this interface. And this interface basically takes a URL as input and allows you to convert any Word document, Word 97 document, into HTML. You can run this, and if you run this particular application, it'll go and fetch that document, and then you'll see it'll turn it back into HTML. And obviously the transcoding isn't perfect, but you can get the actual text out of this thing. The first thing that you would want to do is reverse engineer the application, and you see what how it's implemented. One of the things that one of the things I wanted you to see is that when you do this conversion, after the conversion is made, you get redirected to a result page that is basically a storage bucket. And so all storage buckets at AWS are accessible via URL. And so it's basically the bucket name, which is right here, followed by AmazonAWS.com. And so this is the contents of this is basically pointing into a storage bucket on AWS. And so this is the first thing I wanted you to see, is that if you have a payload that is large, so if you're transcoding a file and you need to store it somewhere in your application, typically large files have to be stored in an S3 bucket, and then you would redirect access to that file to the bucket itself. Okay. So the thing I want you to do is, when you get redirected to that storage bucket, you can basically expose the endpoint of the region that this thing is being run in. So like when you go to this redirect, you can see, unless you're careful, you can basically expose information about the application itself on the backend. Now here, I haven't made any attempt to hide it. So you can see this is running in US East 1. And what you can see is you can actually see the API endpoint. So this is basically run. I don't know if you can actually see this, because no, I can't do anything here. But you can see the API endpoint, and we'll talk about how this is implemented in a bit. Okay, so that it's running in US East 1. And then it asks you, when you submit the conversion, when you click that submit button, what is the endpoint that handles the submission? And so here I have the submit button. And if I inspect it, you can see this is where the submit button is. And then you can see the action that is executed when you click that thing is prod API convert. It's basically invoking an API, take this URL, and then fetch it, and then transcode it into HTML. So that's the next part of the code lab. And then it asks you to bring developer tools up, click on the network tab, and then actually do the transcoding and see underneath what's going on. And then it wants you to take a look at the headers and take a look at what's going on underneath. So that's the next part of reverse engineering this thing. So I'm going to bring up the network tab. I'm going to submit this transcoding, and I'm going to click on this thing. And when you click on this, you can see that this is the request. Again, it goes to that prod API convert. And you can see, as part of this conversion, the form data that says document URL is equal to whatever that URL is in that form is included. And then when you get this, you then, after the transcoding, get a 302 redirect. And as part of that redirect, in the location header, you go and you see that the redirect takes you to that storage bucket. So what the application has done is it's fetched the URL, transcoded it, put it into that storage bucket, and then the 302 to redirect you to where the transcoded image is. And not only does it give you the storage bucket name here, it actually gives you the storage bucket PID of the file that's in here. So again, this is information exposure that we're gonna leverage later on. One of the things with looking at the headers is that all of a sudden you can actually pull out a whole bunch of stuff, information that tells you the operating environment of this API. You can see the API gateway ID for this function. You can see things like basically delivered from CloudFront, so they've enabled the CloudFront services on this thing, and so on. You can tell this is an AWS Lambda that's going on, and that's what these two parts of this code lab are asking you to show. Okay, so the next thing we're going to do is basically test adversarial input. We're going to try and break this particular application. And so when you see this conversion operation, when you see the request header, you can see that the form data that specifies the document URL that comes with a URL attached. Well, one of the things you can test to see is whether or not the API is checking to make sure that this URL is set when you do this request. So that's what we're going to do in the next step. What happens if I turn this and I make this blank and then I submit this form? And when you do this, well, you get that. When I invoke this thing directly without a parameter, you'll see that it gives you an error. And so this thing is not checking to see whether the document URL parameter is set. It's just assuming. And as a result, one of the things that happens is that it exposes the name of the file that's running. So the error log isn't being sanitized in this application. You should never emit this kind of information in the production environment. So unsanitized error messages is what I wanted you to see here. So the path of the file is basically our task index.js. And this is the stack trace for the error. So now you know there's a function called log in this file, and then you know there's a function called exports.handler. And this is where your error has occurred, and that's what these parts of this code lab are asking you to do. The next thing is, as a developer, what would you do to make sure that this thing doesn't happen? That your input parameters are valid before you try and process the request. Now, as it turns out, as a developer, you could actually encode this in your application itself. But if you want to make sure, like, it's hard to make every single developer do the input validation in their applications. One of the nice things about cloud providers is that they give you automated tools to apply input validation across all of your APIs. And that's basically what I wanted you to see next. And so you can see that there are similar things in Google Cloud. So Google Cloud has their API gateway and their Apigee service for doing this kind of stuff. I wanted you in this one to take a peek at the AWS API Gateway Docs and find where you could do some input validation on the APIs, because this is something that's best practice. And so if you look at working with REST APIs, as part of developing these REST APIs, you can see that there's this thing called request validation. And this is the thing that's a good idea for you to deploy on all of your APIs. So what you can do is you can set up a rule that says, you know what, for this particular API, make sure that the document URL form element is set and that it corresponds to a valid HTTP URL. And in this way, you can make sure that the errors don't happen, that these things don't get generated. That's what I wanted you to do in this step, is just to take a peek at validating your inputs when you deploy an API. Okay. The next thing I want to do is see if this thing is vulnerable to command injection. So, for example, if I try and transcode a document and then I put a semicolon after the document URL. Does that document URL get sent directly into a command line to do the transcoding? And if so, can I execute something else? And it turns out it is. And so if I go back to this, application, and I say, well, if this URL is sent into the command line argument at any point in time, then if I can inject a semicolon and say, I want to see what the current working directory is, let me see if this is. And so this is what the next step is. Try and find the current working directory, and you see that this really has messed up the conversion. Something different happened on the back end. And you can see at the very bottom, you can see the current working directory is now emitted. Our task shows up at the bottom. So that's the next step of this exercise. The next step is that use command injection to attain a listing of the directory and show the files that are there. So again, we'll just go back here. And then instead of PWD, we'll just do an LS. And then you can see after I do an LS, you see bar task index.js. Now we can get the source code of this application and look at it. So let me, sorry, I should have done this. You've got a bin directory index.js, the node module, so this is a node application. Package.json, this is the requirements.txt in Python. These are all the packages that this particular node application depends upon. And so you've got some information here. And then it says use command injection to dump out the source file that implements this Lambda function. So that's what we'll do next. I'll go back here, and instead of ls, I'll say cat package.json. And oh wait, no, not package.json, index.js. I'm getting ahead of myself. And when you do this, say, well, what is the source code of this application? And then you can see at the bottom, you can see, hey, this looks like Node.js code right here. And so you can copy this, paste it into VS Code, and then take a look at this application. Turns out I have done this already. So that's what I'll show you next. If you copy and paste it, put it into VS Code, do some formatting. This is the thing that is running the serverless Go application. You can see that there is this child process package that's included. This will allow you to do the command line. Whenever you see child process in an app, you're like, ooh, that might be injectable to a command line. And so you have to be careful. Like when you audit this code, you want to make sure that this thing is done very safely. It needs access to the AWS SDK because it's going to interface with storage buckets and it's going to interface with databases, it turns out. There's another package, Node.UUID. We'll get to that later. The first thing that it implements is a logging function. And it says, for an event, I just want you to log that something has happened. And I'm going to create a log event, and I'm going to put it into the DynamoDB AWS. DynamoDB is a hosted, fully managed NoSQL database that's really popular in AWS applications. So it's basically creating a client, write some data into DynamoDB because all of our log entries are going to be stored in DynamoDB. It's going to pull out information from this event, such as the request ID, the IP address of the person who's attempting to get the transcoded document, the URL, the document URL, and then it's going to call that client and say, put this information into a table, and the table, the name of the table is going to come out the environment variables that I specify with this Lambda. And then it's just going to put that thing using async and async await functionality and store the log event. Okay, so that's just logging. The actual functionality of the application is what's in the handler function. And so this is what gets called whenever you get a request onto the main route. And so the first thing you do when you get that event is you log it. And then you parse out the parameters. So document URL is parsed out. And note that there is no check here that says if this thing is blank, exit. It's just going to assume that this document URL is fine. And then here is the issue. It says let text the result. So this is a text result. Let it be the result of executing a process which does a curl on the document URL directly, and then pipes the result into catdoc. So this is the thing that's taking a Word document and generating the HTML. And I'm going to take this and I'm going to put it into a string. And so this is a problem because this document URL is controlled by the adversary. And so when the adversary puts a semicolon in here, not only do you do the curl, you do the command after the semicolon. And the result of that command is then piped into catdoc, where you get that funny character in catdoc. After you get this payload back, then the next step is to create the S3 object. So you get an instance of an S3 client. And what you'll do is you'll create a random key using the UUID package that we included earlier. So you get this key, you create a S3 client, and you say S3 put object, and the bucket that you're going to put this object in is also the name of the bucket is included in environment variable. And then you say for this key, store this result, and then store it as HTML, and then you allow everyone to read this, and that's what actually stores your transcoded result. And then this does the redirect. So this is where I wanted you to tie in redirect to this application, because this is the thing that then redirects you straight to the URL in the bucket that has that key. And so that's how the plumbing of this application works. Pretty simple application for doing. That is the source code, and this is what I wanted you to look at in order to answer the next set of questions. Let me get to the next set of questions in the lab. Here. Oh, we skipped this. If you go here, so Lambda functions have a timeout. If you do like a sleep 360 as your command injection, you'll see that it basically gives you the 500 error. Hang on a second. If you do a sleep 360 and the Lambda crashes, then this will return an error that will give you this 500 status code. So that's what that part of the code lab is that I just skipped. But that's what this thing is for. Okay, so that's command injection. We just reverse engineered the source code. So show the line of code that the command is injected into, and that was that catdoc thing, the document URL. Show the packages that this file requires. So there was the child process package, there was the AWS SDK package, and then there was that UUID package that we showed. Find the part of the code where the document is placed into the S3 bucket. So that, again, that was shown, and the name of the bucket, how the name of the bucket is obtained, which is environment variables. The database used to store the information, so it was DynamoDB. Those 3 bits of information were stored, and then the name of the table is done through environment variables as well. Use the command injection to dump the content of the package manifest file for the application, and that's the package.json file. So the package manifest says, this is my Node.js application. What packages do I need to install that this application requires in order to run? And in Node.js, it's in package.json. And then, so that's what we'll do next. We'll go and say, well, what does package.json have in it? And you'll go here and you'll say package.json requires node UUID of 1.4.3. So how old is this package is the next question. And then find any known vulnerabilities in this package. And then based on how this package is used, what impact would this vulnerability have? So this is, again, getting you to think about the supply chain that we just talked about, because this Lambda function is probably going to be there forever. And so if it's got this vulnerability and people can figure out that it's running this vulnerable package, then as an adversary, you can get in there and do things. So that's so I know it's node UUID 1.4.3 is the node UUID 1.4.3, and you can see, oh, there's a sneak URL which we've already visited. So sneak, I mentioned earlier, is a way of scanning all the packages in your application to see which ones have vulnerabilities in them. And so this is what sneak is doing. And so you're like, oh, it's been deprecated. That's a problem. First published 10 years ago, last version published 5 years ago. And then you're like, oh, direct vulnerabilities, insecure randomness. Oh, that's not good. Anything less than 1.4.4 issue. And so if you recall, the way this thing was being used in the application, and you can see it here, it's to generate a key that is then used to access, to store this in a bucket. So the fact that this is insecure, this is not truly random, the impact is that it allows an adversary to predict what the key is going to be. Subsequent invocations of the key will be predictable. And then if the adversary knows that, it can basically exfiltrate all of the different keys that other people have created, right? Because it's done in a, so that's the impact of vulnerability. And I just wanted you to just think about that, because this is a toy example that shows you issues in the supply chain and where it would lead to. What is the impact of that out-of-date package? Okay, so that is that part of it. The next step is information. One of the things you can do when you have command injection is print the environment variables. We saw that this application is pulling all sorts of stuff from the environment variables. Well, I want to know the DynamoDB table name. I want to know the bucket name. As an adversary, I want to know all of that stuff. So the next thing I'm going to do is run a print end on this application. So that's what this is going to do. Okay, all right, I'm interested in printing the environment that I have here. And then you scroll all the way down, and I did not do that correctly. It did not complete. And then if you scroll all the way down here, this is a problem. Because, hey, look, there's a session token. Where is the other stuff? So this is a Lambda function name. Here's the table name. So this is what the app pulls out of the environment. So now I know the DynamoDB table. I know the current working directory. I know the secret access key. And the access key ID is down here somewhere as well. Here's the access key ID, and the secret access key, and the session token. So with these three pieces of information, I can now hijack the account that's running Serverless Go. So that's a full jailbreak. The bucket name is also here. Bucket name. I have this thing called in front of me disease, where I cannot see things that are exactly in front of me. But the bucket, I can assure you the bucket is here somewhere. Oh yeah, there it is. Bucket name is right there. And those are the questions that I ask you in this code lab, is to find all of that stuff that's in there, the bucket name, the table name, all of that thing. Okay, so the next part of this is AWS, the S3 buckets. As soon as you have an S3 bucket, there is a well-formed URL that can allow you access directly via a website to your asset. Now, if you have set your bucket to be public, then anybody can access given that URL. So the well-formed URL is this: https:// bucketname.s3.amazonaws.com. And so the next step is we'll visit this. I'm going to go to this bucket name, which is right here. I'm going to copy it, and I'm going to go directly to it. And when I go through this, you can see that I have a manifest that shows me every single object in this storage bucket. Where all of these keys, and so now what I can do is for any one of these keys, I can copy this key and I can now access anything else. So anyone else's transcoding that has been sent to this application, I can now directly access someone's previous transcoding execution. Okay. So this says find a document that has been converted by another user, because all you need to do is directly access that key and then get that converted data. Okay. So we saw that the account credentials are stored in the environment variable. So the next thing I'm going to do is I want to actually hijack that account. So I'm going to ask you to bring up the AWS CLI and configure a profile using the access key ID, the secret access key, and then I want you to actually initialize the session token in that. So let me do that next. I have Cloud Shell here, which, oh no, timed out, sorry. Oh, comes back up. AWS configure -- profile serverless Acme. Oh, shoot. And then I am basically going to pull out from here the access key ID. Change from last time, the secret access key. And then I'm going to leave that US East 1, and then default format is none. And then I am going to edit the credentials because I need to fit the short-term session token. And then hopefully this thing won't expire by the time I need to use it. So I will copy this thing over. I copied too much. This is where it ends, right here. And then what I'm going to do is do an AWS S3 LS S3 : / I think that's what I wanted. Oh, actually, I want to get the caller identity first. So one of the things that you can do is you can introspect what this credential, who has this credential. Now, if you have your permissions set inappropriately, you can do this introspection, which is basically what these permissions are set up to do. But this might actually not work in other deployments. Security is done right. So secure token service is what AWS STS is. You're trying to figure out who, which account is this token good for? And that's by saying, here's a token, the caller identity on this thing. And then you can see, oh, this is the user ID. So it's the function convert role that's being used to access this, that's being used to run this serverless application. Okay. The next thing I want you to do is see whether or not you can list the contents of that bucket using this profile. And you should be able to, right? Like this profile has to be able to write and objects into that S3 bucket. It actually doesn't need to read in this S3 bucket. All it's doing is put objects. If you recall in the application, all it's doing is S3.put object. So it really only needs the put. But for some reason, it's been given all of the access to the S3 bucket. So this should, like, if you did least privileges, this command should have been denied, right? Like, this profile should not have listing privileges on the bucket, only putting or writing privileges. And so we're going to go to the bucket name and then do an AWS S3 LS on this bucket. So this is the name of the bucket, and I'm going to use this AWS S3 LS S3:/ that serverless bucket profile serverless tech. And then you can see now it has this credential. Because you have been able to get this credential, now you have access to everything. And these are all the files that got created since the last time I reset this level, which was like last month. So this is a really popular application. You see all of your exercises. So I can see what everyone has done and the transcoding result of all your operations. Okay, so that's not good. That's basically full-on exfiltration of the backend. So then, based on your knowledge of what this application actually does, I wanted you to walk through the permissions that were set and to see whether or not they were over-provisioned. And so that's what this is. The first role is a basic execution role. And this is actually the role that is set up appropriately. And if you see, so this is obviously, this is not something you can see. This is running on my project. And so this is something I pulled out of the application. And if you see this role, it's just giving you access to write CloudWatch logs. This is actually fine, right? Like it's doing some logging information and it's only being allowed to write the logs and not read them. So this doesn't have the issue that that A2 finance level has in Thunder CTF, where you're actually reading the credit card data out of the log files. If you hijack this account, you couldn't read those credit card data, except there are other roles here that are also attached that are over provisioned. So that's what role number 2 is. Role number 2 has a DynamoDB role that is given read and write access to DynamoDB. Now, if you see the application, if you recall, the only thing we did with the DynamoDB client was a put. That only requires write access. And so our ability to access the DynamoDB table and read it is not necessary. And so that's basically what I wanted you to say. You never need to read from this table using this particular role. Okay. The next role is the last one, and the last role specifies the access level to the storage bucket that you want this application to have. And if you look at the S3 permissions that are allowed, it's list, read, write, and then permissions management. This is way over provision. You're only doing a document into this level. And so clearly the write is the only thing that's necessary here, but it's been given all of these permissions. And again, you have to reduce the privileges on this thing to secure it. But this thing is intentionally insecure, so that's why it's there. Okay, but you know, if you wanted to, so say you were actually trying to fix this application, then you would get rid of the command injection, you would sanitize the error logs, you would reduce the privileges on these roles. And so start thinking about that, because eventually we do want you to be able to fix this thing. So there is that. And this is why this is, you know, it's a simple exercise, but it's a really long code lab just to show you these. The last thing is the data exfiltration. I've been given a DynamoDB permission to basically dump all the tables, read all the tables. So what I can do is I have a command injection attack, and then I have the account that's running the application has read access to the DynamoDB. Now what I can do is I can invoke Node.js on a JavaScript script that I can send, and I can use the permissions of the server to then scan the entire DynamoDB backend. And this is because of that over-provisioned role and the command injection that I now can exfiltrate all of the database. And so this is what you're going to do, and you're going to basically run this using this. So in the web interface, I'm going to give it a bogus URL and say I'm going to terminate the command. And then I want you to run Node.js on this script that I'm going to show you here. And what this is going to do is it's just going to log to the console the entire contents of the DynamoDB scan. So that's what I'm going to do next. I'm going to go back to this repository. And I'm going to say, give me this. And I'm going to submit this thing. And then you can see all of the transcoded documents. And so you can see this document was, I was trying to transcode was google.com with a bunch of echoes. And so you see everyone's, all your IP addresses here of all the attempts that have been made. So some Portland State ones, some other ones that are outside of Portland State. And you can see all of the accesses. Well, it's limited by 200, or I forget how much it's limited by, but it's limited by the scan will only give you, I think, 200 by default. Okay. The next step is you can filter out your accesses using more JavaScript. So I can actually, in my DynamoDB query, I can say filter out the attributes and make sure that the IP address matches a particular IP address. I'm going to have you do that next. So I'm going to go to ipconfig.me, figure out what my IP address is. This is my IP address. I'm going to copy this. Well, I'm going to copy this program that allows me to query this thing. Then this here. Okay, and then I will filter based on my IP address. So this is my IP address. And I am going to filter all of my accesses out. And this is what I wanted you to do, Code Lab. And I submit this. And then you can see all of the documents that this particular IP address has accessed. And you can see all of the commands that I just ran in this class show up. And that basically, it tells you how many entries that were scanned. So basically, there's been about 500 requests. And then it gave me 20 as part of this. Okay. And then it asks you to take a screenshot and a conversion from another user.